Today we're going to do Module 1, Lesson 9. Module 1, Lesson 9. And we're still working on exponents. Let's see. I was trying to see if I could add another page. This is a new format for me. So let's see. Okay, we're going to, let me close this. Okay, we are going to talk about writing things with single bases. So if I have 4, they want me to write it to a base of 2. So here's 2. How many 2's are in 4? Right, 2 to the second power would be 4. What about 4 to the third power? So with the first thing, so we know 4 is 2 to the second power. So 2 to the second power, and how many of those do I have? Right, 3. And then I know I'll multiply my exponents, so I would have 2 to the sixth power. Then 8. How many 2's in 8? Right, 2 to the third power. And then 8, I know, is 2 to the third power. And then I could say times 2. So I would have an exponent of 2. And 2 times 3 is 6. So 2 to the 6. But look, both of these are 2 to the 6. So that means that 4 to the third is equal to 8 to the second. So if you looked at this, and I had to pick, if I'm giving you 4 to the third's dollars or 8 to the second dollars, could you pick which one is larger? No, so sometimes we need to look at things in smaller increments so we can compare. We're going to do the same thing here with 5. So 125 is 5 to the third, because 5 times 5 is 25. 25 times 5 is 125. Now here, 125, so I know I just did 5 to the third is 125 to the negative 6th power. I know I have to multiply power to power, so that gives me 5 to the negative 18th power. And remember, I don't want a negative exponent, so the rule we used the other day was a negative exponent rule where I flip my base and change the sign. Then let's see over here. So this would be 5 to the third. And then here, 125 to the 6th. So I know that 5 to the third is 125 to 6 times, multiply my exponents, so 5 to the 18th. So again, we can look at find patterns. So this, and this are equal because these two are equal, so I know that those two are equal. So we're always looking for patterns to see what's equal. Let's see how we're going to use these things. Okay. For problems 3 to 6, not all of these are we doing. Okay, we're going to do this page. Use the properties and definitions to write each expression as a single power. So I have 4 and 2 to the 9th. Out of those 2, I know that 2 can go into 4 2 times, so 2 squared is 4 times 2 to the 9th. And I know when I multiply exponents with the same base, I keep the base, and I add, I don't know what I'm doing, I add my exponents, so I have 2 plus 9, so this is 2 to the 11th. Let's look at 4. 9 and 81. I know 9 times 9 is 81, so I have 9 to the 9th times 1, 9 to the second. I was thinking 9 to the second, and I wrote so 9 to the 9th. If I multiply this out, so it's 9 to the 9th divided by 9 to the 2nd. And I know I keep my base and I subtract my exponents. So that gives me 9 to the 7th. Do the same thing here. 1 to the 7th times 149 is 7 squared times 7 to the 5th power. Well, that looks really hard to do, but I know I can do, if I have 1 times x to the n power, I know that is equal to x to the negative n power. So I can do 7 to the negative first power times 7 to the negative second power times 7 to the 5th power. So that helps me. So I use this rule to change these two. Now I know I just add my exponents. So -1 plus a -2 plus 5. I keep my base. And when I do -1 plus a -2, that gives me a -3 plus 5, that gives me 2. So that equals 7 to the 2nd power. 25 and 125. So if I remember on the page I just did, I know 5 squared is 25. And again, I can't get rid of this 4th power. I know this 4th power has to go with my 25. So 5 squared. And then I knew 125 was 5 cubed to the 7th power. Now I know here and here I'm going to multiply. So 2 times 4 is 8, so that's 5 to the 8th power. Times 3 times 7 is 21, 5 to the 21st power. I keep my base and I add my exponents. So that's 5 to the 29th power. 5 to the 29th power. So again, I am using things I already know, plus my rules of exponents, to solve these problems. Now I want to go over your rules of exponents again, and we're going to make a list right here. So the first thing we did was x to the m times x to the n. When I do that, I add my exponents. The next one we did was a power to power. So if I have x to the m times n, I multiply those exponents. Then if I had the other power to power, if I had x times y to the m, that exponent would go to each thing in the parentheses, so that would give me this. And then I know x to the 0 power, anything to the 0 power equals 1. My other rule was if I was dividing x over m divided by x over n, then I subtract my exponents. And the last one is if I have a negative exponent, I move that exponent to the opposite piece of that fraction, denominator or numerator, and I change the sign of my exponent. So these are the rules. If you know these and can use these, you will be good to go for the test.